now, and I'm going to start checking off. You have 2 assignments that you owe me total. You have page 97. You had 3 to 28 on Thursday night. I did not walk around and check it off on Friday because I was busy helping you guys with your word problems. So you owe me Thursday night. I'm going to walk around and check that off first, page 97. Again, it was 3 to 28. And then on Friday in class, you worked on 97, 98. You had 37 to 45. I'm also going to walk around and check that off. So while I'm walking around and checking that off, here's what I want you to do. There's a warm-up in our 2-1 notes. Today is very much just a review day of y equals mx plus b. I need you to help me find some m's first. So I want you to go ahead and take a look at this warm-up. It's in the 2-1 note packet. And then I want you to try example 1 as well. So you kind of have 2 warm-up sets to do. You have 4 slopes, and then you need to describe those 4 slopes in example 1. So that'll get us off to a really good start for today. All right. So this actually looks really good. Whoops. TMI. Sorry. Okay. Just in order for your answers real quick, because if we can't get these right, well, then we have no business really doing the rest of the lesson. Your formula for slope, you folks commonly know it as rise over run. When you rise, that indicates the vertical displacement or the change in your y values. When you run, oh, heavens to Betsy, that's me. Write me up. Okay, so we do y2 minus y1 over x2 minus x1. I had my spinner on from before. Didn't shut my phone off. Okay, so yeah, we have our rise over run. Change in y's over change in x's. So part A was a half. Anybody have any questions? Not get 1/2, not know what they did wrong. You're good? Looks pretty good as I walked around, so I believe you. Part B, the answer there was -1/2. Part C, that's undefined. We can't divide by 0. Nobody can divide by 0. If you think about it, it actually makes sense. You're trying to take a number and divide it no ways. That can't happen. You can't take something and divide it no ways. The division actually doesn't take place then. So it's an undefined operation, and that's why we say that's undefined. Part D. You get 0 out of -9. When you have no slope, you have no rate of change between your points, which means that you actually get a horizontal line. It doesn't go up or down at all. That's it. Okay. Does anybody have any questions about these slopes? Okay, so if you look at example 1, right below this warm-up set I gave you, I asked you to talk to me about what you noticed for parts A, B, C, and D with regard to, is the line increasing, decreasing, horizontal, or vertical? So let's take a look at part A. We have a slope of positive 1/2. What can you say about that line, John? It's increasing. Very good. It does increase as x increases, y increases. If you were in any doubt about this guy increasing, well, what could you do? You could draw a picture. So you might have the point over 2, up 1, and then over 0, 0. If you connect those 2 points, you get a line that goes up. So when in doubt, draw it out, right? That rhymed. I didn't plan that. So that line goes up. Part B. Go ahead, John. It is. It's decreasing. So in general, we're coming to understand that when you have a positive slope, your line increases. When you have a negative slope, your line decreases. Now, if you were doubting this, you could always draw it, right? You have the point -2, up 1, 2, 3. Oh, right in the middle of my S there. And then over 2, up 1. Connect those points. You do see that you get a downward sloping line, a decreasing linear function. Part C is undefined. Anybody know what kind of line that makes? If you plotted it, what would you get, John? Yeah, both Johns. Yeah, is that what you're going to say? Sorry, you're like right behind each other. Yeah. Yeah, you would get a vertical line. Very good. This thing fails the vertical line test. Well, hey, because it's a vertical line. If you look at the problem, just thinking back to the beginning of the chapter, I like this because it kind of makes the chapter come full circle for your test that's on Friday. what we get is one input that's mapped onto more than one output. You can't have x values that repeat. Remember when we did those t-charts and you had to compare and decide what was a function and what wasn't? Well, this would be a prime case of something that can't be a function. And it can't be a function because it would fail the vertical line test. Because it's a vertical line. No worse offender. No worse offender. All right, part D. That's actually a horizontal line. It's already kind of written there for you on my slideshow. How can you tell it's horizontal? So you see there's no change because the whole fraction turns into 0. Eddie? Yeah, there's only a y value. Yep, good. It kind of stays there. All right, so in general, we got an increasing, a decreasing, a vertical, and a horizontal line depending on the value of our slope. Okay, so that example should be done. You can go ahead and turn the page. Because this is also for you folks to think about. Little brainstorming session. If you turn the page, you're going to see a rectangular box. Everybody see it? In that box is an equation y equals mx plus b. What I want you to do in that box, and you can do it with a neighbor if you'd like, is just brainstorm about what you recall about that equation. So like, do you know anything about m? Do you know anything about b? Do you know anything about x or y? I'd like you to just jot down maybe one or two things that you might know about that equation in the box. And then I'll show you what my other two classes have come up with throughout the day. I'm going to check this last row of homework real quick while you guys do that. So you're brainstorming y equals mx plus b. John had it right for the most part. You just have to go to where your b is. A lot of my students will call this the starting point of the graph. You start graphing where your y-intercept is. That's the place where the graph crosses the y-axis. And then to get from point to point to point, you want to count your rise over your run. And John did talk about that a little bit. Remember, your rise is just the change in your y values, and then your run is just the change in your x values. So for instance, on part A here, sorry, I'll screen shade this. Forgot it was all done there. So we talked about that. About this. All right, just so that it's not too overwhelming for you, I want to talk about how this line was graphed. First, I drew my attention onto that +1 right there. That +1, that takes the spot of b in y equals mx plus b. So what I'm going to go ahead and do is go up one space, and I put a dot. And then to get from point to point to point, I count off my rise over my run. In this case, my slope was 2. You know that you can write just 2 over 1, right? So you got to count your rise over your run. How far up or down you go in comparison with how far you should go across. So what this is saying is that quite literally you want to go up 2 spots, 1, 2, and then over 1 to get to the next point. And then we go up 1, 2, over 1 more to get to your next point. And I usually repeat the pattern 1 time in reverse to get my line. I have a question for you. You're going to have about 6 of these to graph tonight for homework. That's why you grabbed graph paper when you walked in. So yeah, I have a question for you. How many points do you have to graph in order to get a line? 2 points make a line. 2 points make a line. So you actually only need 2 if you're following the letter of the law there. When we did our t-charts though, we did graph 5, but those weren't always lines. Sometimes those were parabolas or other functions. So when we plot using the point plotting method with a t-chart, you're going to do 5, some negative, some positive, and then 0. But for these guys, once you get your y-intercept and another point, you're done. Sometimes you could just do the x and y-intercept too. All right, you try part B. You ready? Do it. Do it up. All right. So the walk around, that looks pretty good. Everybody has their y-intercept at 2. And then to get from point to point, you see how we go down 3 and over 1? This results in what we said earlier. We have a negative slope, so you get a decreasing line. Sometimes our lines aren't increasing or decreasing. Sometimes they just don't go up or down. Sometimes they're horizontal or vertical, like in the next examples. What you'll see in part C and part D are examples of constant graphs. there was no slope to these particular lines. Do you see how I put in a 0x there in my equations? So let me talk to you a little bit about a really easy way to remember which one's which, because quite frankly at this level, you folks know when you see y equals a number or x equals a number, you know that that's either horizontal or vertical. But what I see at this level most commonly with my college algebra students is they just get confused as to which one's which. So let me just give you a quick little reminder about how that works. Do you see in part C, we're asked to graph the line y equals 2. So I go on to the y-axis where y is 2, and I put a smiley face. Do you see that? And then I ask myself, well, like, I know this is supposed to make a straight line that's either horizontal or vertical, but which one is it? Well, honestly, if I were looking at that smiley face and I drew, you know, what we might call a vertical line, well, I've just traced out the y-axis. That's not what this problem is asking me to graph. It's asking me to graph the equation y equals 2. So what I want to go ahead and do is I don't want to trace the y-axis. I go in the other direction. And that's how I got this horizontal line right there. That horizontal line satisfies the equation y equals 2. Models the equation y equals 2. I followed the very similar process in part D. So I basically went to where y is -3, right there on my star. And then I asked myself, well, is it horizontal or vertical? Well, if I drew the vertical line there, I'd be tracing the y-axis. That's not right. So I go the other way. The horizontal line, y equals -3, is that guy right there. So that's a little refresher there. If it said x equals a number, well then yeah, we would draw our vertical lines instead. Okay, last little bit of this part of the lesson, because then we have to flip it around. Right now we're practicing, given an equation, make a line. In the last example today, we're going to say, hey, here's your line, write the equation. So we have to go backwards today too. But one last go around, I wanted to show you one last technique for y equals mx plus b, because like I said, you have 6 of these to draw tonight. All right, so the first, for instance, that I wanted to show you was part E. And what you're going to see in part E, see the equation x plus y equals 2. And you're like, what's up with that? It's not in y equals mx plus b form. I can't find the slope, and I can't find the y-intercept. What you could do is just solve it for y. It's real quick and easy. So all I did, do you see what I did there? I just subtracted x from both sides. If I just subtract x from both sides, on the right side of the equation, I get -1x and +2. So it's very quick and easy in that regard to identify the y-intercept and then the slope. So my y-intercept is at 2, and then I have a slope of -1. So I went down 1 to the right 1, down 1 to the right 1, so on and so forth. In the next example, I just wanted to remind you of something that'll be on your Chapter 1 test on Friday. And then this is like another method you could use. Remember, I think John said it, both John said it, you need 2 points to make a line. Well, you could also just use our intercept method for graphing. So just to review that with you real quick. Do you remember how to find x-intercepts from the beginning of the chapter? It was a long time ago. Do you know, John? Yeah, you let y equal 0. And then to find the y-intercept, how do you do that? Yeah, very good. So that's what we're going to do. If you want to find the x-intercept, you let y equal 0. So we're, you know, basically subbing your 0 for y. Solving for x, you divide both sides by 4. You get 1.25. And then lastly, for our y-intercept, you let x equal 0. So if you let x equal 0, you have 4 times nothing plus y equals 5. Y is 5, so you get 0.0, 5. Questions about that? Looks pretty good. You ready to go backwards? I think you are. You look ready. Let's do it. Last example of the day. And then tomorrow, we just kind of say, hey, you know, what makes lines parallel? What makes lines perpendicular? Last example of the day is our example 3 here. We are asked to write an equation for the line. So essentially, what do I need to find? If I want to write something in y equals mx plus b form, you need to identify m, and you need to identify b. If I look at part A, oh my goodness, I'm super excited because, do you see what I see? Do you see it? Do you see it? Bam, there's the y-intercept right there. The graph crosses the y-axis at a nice clean point. That doesn't happen often, but when it does, I'm totally going to use it. That point there is 0, -4. What goes on the smartboard goes in your notes. That is my B value. So I know what B is right there. B, this graph crossed the y-axis at -4. So my y-intercept is -4. The next thing I want to do, if I want to write an equation in y equals mx plus b form, I need to find m. I need to count off my rise over my run. So I'm going to go ahead and do that. To get from point to point to point, I notice I'm going up 1. So I have a rise of +1 because I go up 1. And then I go to the right 1, 2 spaces. I also notice that this line is increasing, so my slope must be +1/2. So if I want to write an equation of the form y equals mx plus b, I'm going to take my m and take my b and fill them in. So this guy's going to be y equals, my m was 1/2, x plus my b value. -4 was my b value. So I have y equals 1/2 x minus 4. Are there questions about that? Part B is a little trickier. I don't know if you see that there. I have a y-intercept, but it isn't pretty. So I'm going to go ahead and find 2 points first, because ultimately all we need is 2 points to make a line. I ask that you use the same points I do. So we're going to use the points -8, 0 and 2, -3. And I know at the very least I can calculate the rise to run for those. So I can calculate y2 minus y1 over x2 minus x1. You get -3/10. You could write that as -0.3 if you want to. Same thing. So I have my slope. My y-intercept, I want the exact value for that. I don't want the approximation. It looks like it goes through at about -2.5, maybe a little less than that, but we want it exact. So what we're going to do is we're going to use our shell, y equals mx plus b, and we're going to fill in what we know about m, and we're going to grab an x and a y value. I'm going to use -8, 0 because I like 0, makes the problem easy to work with. So I have my y value of 0 and an x value of -8. So I have 0 equals 0.3 times 8 is 2.4 plus b. Subtract 2.4 from both sides. I know that my b value is -2.4. So in step 1, I find my slope. And in step 2, I solved for b. Ultimately, in the last step, you have to write the equation. Y equals -0.3x minus 2.4. You have bookwork tonight. Don't forget your graph paper. And I'll see you tomorrow.